Thanks for coming out. It's good to be here on a beautiful springish day. Okay, so first I want to acknowledge people so I don't forget to do this at the end, but this is a culmination of a lot of work from a lot of people, definitely not just myself, but I'm happy to be able to share it with you today. And I'll present sort of the general overview here is that I'll talk a little bit about a paper that was just published as a little bit of an introduction, sort of first middle part of the talk. And then I'll talk more about sort of the title of the talk, which is work in progress. So I'm happy for feedback. We're going to start kind of big picture, and then we'll narrow into like a more specific research product, but just to give you an idea of what's to come. Okay, so we all know where we are in sort of the global state of carbon dioxide concentrations and climate emissions. We're in undeniably new climate territory here. We have oceans that are about six inches higher than they were at the turn of the century, the turn of the 20th century. Glaciers are disappearing, right? We are in new climate territory, and we're trying to figure out what to do about it, right? One thing to do about it is we could suck some carbon out of the atmosphere, right? So there are ways of thinking about trying to do this, move carbon dioxide from the earth with machines. But we could also try to block some of the, do some geoengineering to block some of the extrasolar radiation coming in to keep our planet cool, right? So these are all things that people are proposing. None are quite science ready or planet ready at this point. But one thing that is gaining a lot of attention and a lot of excitement and funding and investment are things like natural climate solutions, right? So natural climate solutions are ways to use landscapes to mitigate carbon dioxide emissions or methane emissions. And these are becoming very popular in part because there are so many different actors with incentives aligned to around these kinds of these ideas, right? So we have economically minded actors like governments and companies that are excited about these as ways to offset their own emissions or promote their own reputations about being carbon minded and net zero goals. We have environmentally minded non-governmental organizations and actors that are excited about these because it brings ways to fund in things that they've wanted to do for a long time, and the potential for funding is very, very large. And these natural climate solutions, there are a variety of different types of things that we can do to try to use nature to help with the climate crisis, including things about protecting certain ecosystems, forests, wetlands, grasslands, better managing timberlands or croplands, or restoring forests and wetlands and other types of ecosystems too. And so these hold potential for helping the global carbon crisis. And some estimates have suggested that up to 30% of our carbon dioxide removal goals could be met through these kinds of natural climate solutions, right? That's pretty big. It's not the complete solution, but that's a large part of it, right? So things like protecting trees or replanting trees. But certainly if we're to get to that 30% goal, there are lots of things that we have to think about as well, right? There are trade-offs with other types of conservation potentially for biodiversity, or trade-offs with agricultural production, so food security concerns. There are other land use issues that are going to run up into problems if we really restore or protect this amount of land that's needed to meet these kind of carbon sequestration goals. So urbanization or other kinds of land uses. And there are also big concerns about how this impacts people that might live in places where these kinds of restoration or protection activities would be most likely possible, right? So this is a report that I worked on with the Rights and Resources Initiative that just came out a couple of months ago, that was looking at carbon rights for indigenous peoples and local communities and Afro-descendant populations in a set of 33 countries that have large carbon sequestration potential. So these things are all sort of issues that we need to think about when we're thinking about these natural climate solutions, right? So for natural climate solutions to work, for them to be viable and actually legitimate, we need to understand what other things happen whenever you develop these natural climate solutions. So what call these co-impacts. So there could be co-benefits that come along with natural climate solutions, but there could be trade-offs, right? So we need to understand like how restoring or protecting or better managing lands, how that impacts other ecosystem services, how it impacts biodiversity, but also how it impacts a suite of human well-being outcomes. Okay, and so that's the first part of what I'm going to talk about today is that first question. And the second part of the second thing that we need to know for these natural climate solutions to work is how do we make these work in real places for real people, right? And so that's the second part of the talk that I'll present today. Okay, so yeah, so the outline here, which will follow along with my little outline below on the bottom there is I'll talk about an evidence map, which is this paper that I mentioned at the beginning that's actually just been published. So we'll talk about the evidence map very briefly, just as sort of a setup to the other spatial, the other components where we'll talk about where and how to do the restoration. Okay, so there, I mentioned that there are a lot of these different types of actions that we can take that could be useful in thinking about using land to mitigate carbon, right? But it covers a whole suite of biomes. It covers a whole different types of activities. So where do we start? There's so many different NCS actions that we could potentially evaluate. I think probably the most famous one, if you know this literature, is the Griscom paper from 2017 in PNAS that outlines like 20 different actions and lists the carbon sequestration potential for each of them, right? So it's a lot of things to try to cover if we're really trying to understand this from a literature-based standpoint, right? And then on the other side, it's like, well, if we're really looking at co-impacts, like what other things happen? There are also lots of different types of co-impacts to consider. Okay, and so we set out to try to cover this space, the literature space, to understand all the NCS types and a suite of co-impacts. This is a bit of a challenge. And there are others that have covered pieces of this space before, but we at least attempted to do something slightly more encompassing. And we used machine learning methods, not like we say AI methods, right? But AI in the big sense of AI, not in just the small sense of LLMs, right? But we use AI methods to help us along the way. So our process for doing this was to develop search strings for each of the different natural climate solutions and each of the different well-being or co-impact outcomes that we wanted to consider. I'll show you a table of that in a second, so you'll get a better visual of that. But we developed search strings for all of these things. Scraped Web of Science and Scopus to gather all the literature we could find that was captured in the search strings we developed. We then filtered through the articles for, it's a typical like relevancy classification. Is this article related to what I want to look at or not? But we started out that first stage, we pulled 2.28 million papers. So that's a lot. It's more than we can really cover alone. So to filter through these, to do the relevancy classification, we used clustering algorithms and to find a cutoff for where these clusters look to be relevant or not. That got us about halfway through the set of studies that we had. We then used this set of studies after we did a relevancy classification. We fitted all the abstracts and titles from those studies. We put them into, we did topic modeling on them, so natural language processing topic models, and we developed 800 different topic clusters. We then human reviewed each of those topic clusters to identify clusters of papers that were relevant or not, and filtered those out as well. And so we sort of had humans in the loop in multiple parts of these stages, but the biggest one was this fourth one here. And that got us down to 364 what we call like high probability topics that related to the things that we wanted to study. Okay. That still left us with 250,000, more than 250,000 papers though. And so we then used, but they were then all classified into different, into our different NCS types and to different well-being categories, right? And so from this, we're able to extract this evidence map for at least being able to say what we know for what is out there. And from that final set, we extracted other variables, like we geolocated some of the studies that we could. We extracted variables on equity, namely looking at any studies that included things around indigenous peoples and local communities. We looked for cost information, which was marginally successful. And we extracted species level information too. And those are sort of ongoing parts of this that are still in development, but I'm not going to talk about those here. Okay, and we think analyzing 2.28 million abstracts would have taken a very long time, but at least after we got the sort of process set up, then we were able to sort of, compress what would have taken many, many years and rooms of people to do. We were able to compress that into just a few weeks of actually going from data collection, extracting from Scopus and Web of Science, running it through our pipeline, and then being able to have a set of results that we could then look at as an evidence map. Okay, so what evidence exists? This is our evidence map. And so what you're looking at here is all of the different NCS types. So these are the 20 or so from Griscom. And then we have different co-impact categories on the bottom here. Okay, the shading, I'll show you a little more detail on what some of these are in a second, but just to review the shading here, like darker shades means higher numbers of papers represented in that box. And the little squiggly lines are changes over time for that particular subcategory. And the squiggly lines are divided into things that are light yellow-ish and reddish. And those are meant to show how much that category is growing relative to other categories in the database, right? So are we gaining more evidence around a certain category, or is that evidence base decreasing relative to the total, right? Because we know, publications have all increased over time, publication rates have increased over time, and so we're trying to assess, like, well, in relative terms, is our evidence base growing or shrinking for each of these categories? And so that's what the color coding is of the lines in there. And the co-impacts that we looked at here, so this is a blown up, sort of the x-axis. So we looked at, economic and material living standards, some general idea of like human well-being broadly classified, and other, a series of these, of what we might call human well-being co-impacts that one could think about assessing related to some restoration or protection or other kind of management activity. And then on the end here, we have also environmental co-benefits. So that might be ecosystem services in some other regard that's aren't carbon, and biodiversity co-benefits. So we look for those in our evidence base as well. Okay. And what I'll focus on here today in the latter part of the talk are restoration activities. So this would be, forest restoration or afforestation, could be grassland or coastal wetland restoration, mainly mangroves, or freshwater restoration, which would be mainly peatlands. And we took our evidence base then and said, well, we have evidence, but what does that really tell us? And so we looked at countries where we had an evidence base against the amount of carbon potential sequestration that country could have. And so we then divided this evidence base into places where we need more evidence and places where we're likely more ready for action, right? And so this is this need versus action areas. So if you're low evidence but high need, then you're low evidence but high restoration potential, high carbon potential, then you're in a need area. You need more evidence in those areas. And if you're in the high category, then you're more likely ready for action, right? But this kind of evidence map just gives us, and this is the restoration side, more zoomed in so you can see a little bit better. But this just gives us an idea of what evidence exists. It doesn't tell us even the direction of impact, right? So we don't have a sense just from this alone, does restoration lead to better human well-being outcomes or worse human well-being outcomes? We just have, this type of restoration activity has papers that also talk about this kind of this type of human well-being outcome, right? And so to understand that directionality, we need to dig into those papers a little bit more, right? And so we've started doing that with sort of slices of this broad evidence map, but those are sort of ongoing efforts as well. Okay, so that was the evidence map, and that's that paper. The first author is Charlotte Chang, who's part of the working group and was on the first title slide that I gave. And so that paper, the evidence map paper, is Chang et al. And it just came out earlier this month. Happy to send it to anybody if you'd like to see it. But the second part here, which I have a typo in this slide, is trying to think about how we prioritize where these restoration activities might take place. Okay, so what we did here for this is we said, okay, well, we have an evidence map, but we really need to understand more about where people are working and how to understand where we might actually try to implement some of these things. There are tons of different options. And so all kinds of decisions that need to go into how you would choose any one of these categories. And so how do we better understand that? And so we took this sort of slice from our evidence map methods, which gave us our final database over there. And we took all the authors from the evidence database, and we sort of had a year cut off for papers that were published more recently, and deduplicated authors that appeared in our database more than once, first authors. And we sent authors a survey. The survey had multiple parts. It's very possible that some people in this room might have received the survey. And so there were lots of things several things that we asked in it. Hopefully it wasn't too long. But one of the things that we asked is, what of these land-based mitigation strategies, of these natural climate solutions, which ones would you think would work best in the place that you work, under what conditions? And so to answer this, we used a discrete choice experiment. And these are hypothetical choice methods that, when you don't have empirical evidence for how to make these kinds of decisions, you can create these hypothetical choice experiments that help you put people in a situation that simulates that kind of decision context that you want them to, they want to study or evaluate. Okay, and so I'll give a little bit more detail on what this discrete choice experiment actually looked like here. Okay, so this discrete choice experiment, we applied it only to the restoration side because we needed to constrain it to be a little bit more controlled. And so we asked people to take on the role of an advisor to a program manager that had a budget, large budget, to choose among different restoration activities. Okay? And then we said, we varied. So choice experiments, you vary the different types of attributes that you put inside the choice that they're making, and you can then see how their choices differ based on the different attributes that you embed into the choice experiment itself. So the main attributes we varied here were the location, so the region of the world that it was in, the social context, so its population density and sort of relative wealth within that region, and the percent of the budget, the percent of the total program budget that they would allocate towards this. And if you're a choice experiment person, you use these, it's a bit of a different choice experiment setup, okay? Because we're asking experts to evaluate a public choice not usually choice experiments are set up to elicit private willingness to pay measures. This is a different context, and we have anyway. So there's a lot more that I can talk about with the choice experiment setup if you want to talk about that, but it's a little bit more sort of like methodological. So I'm not going to go there. I'm just going to say this is what we did, and let me show you the results. But here's what the choice experiment actually looked like in the web form that the respondents would receive. So here's their role. We gave them the different types of things that they would be evaluating on. And here's what an actual choice card looked like. So they'd be presented two different projects. Project A, an agroforestry project, or Project B, avoided grassland conversion. And they would then be told what location it's in, so a peri-urban or a suburban area in a region, a continent with medium levels of income. And here's the proportion of funding from your funding portfolio that you would allocate towards this type of project, right? So this is essentially set up so that we can vary these different things that are bolded here and see like agroforestry is more preferred in Africa with medium income levels, right? And so we can see where across all the experts that we're interviewing, where preferences lie based on these sort of social and location-based contexts. And these are the different attributes that we varied and the different levels of those attributes that changed with our choice experiment setup. Okay, so each respondent would get 3 of these, and then you set up these choice experiment designs so that over many people, you get lots of variation among all the attributes, and you can statistically back out how preferences change based on each of these attributes. That's a more close-up version. Should use that. Okay, and so the econometric strategy here, I won't go into this too much, but if this is your thing, it's here. But we've estimated the choice probabilities in sort of standard choice experiment way. The different thing that we do here as well is to compile then the results of our choice experiment and then use them to spatially evaluate how restoration, this expert-informed version of restoration priority. Okay, and so we take the results of the choice experiment. They give us prediction probabilities, and then we're able to then do a spatial prediction exercise where we say, okay, for a pixel that has the location attributes that we had from our choice experiment, here's the most preferred restoration option that experts told us about. Okay, and so from the results in step 1, we get these predictive values in step 2 to then sort of spatially display the results. Okay. Ooh, formatting. And so to get the data that we need, I'm sorry for the formatting issues here, didn't translate well, but to get the data that we need to say, okay, for each pixel, we need a measure of regionally relative wealth, we need population density, we need an idea of what a land use constraint. You can't just restore forest anywhere or put a wetland anywhere, right? It needs to be contextually appropriate, and the continent. So we use these data sets to for each pixel, we put those data sets in here. The biggest one, or the one I think that is most maybe interesting, is how we characterize these land use constraints. So we took the Nature Conservancy's, they have a database of a nature base, they call it nature base, but it's a database of a lot of spatial layers of different types of natural climate solution related information. And for inside nature base, they have restoration potential for the types of natural climate solutions we've asked for here, right? So they have which areas of the global landscape are forest restorable, which parts of the landscape are restorable for wetlands or for peatlands. or which have agroforestry potential. And so we're using those as constraints on what is possible on the landscape. Okay. Okay. All right, so recruitment of the people that were in the survey. So we have our evidence map is where we pulled authors from. The Web of Science and Scopus gives you most of authors' contact information, including an email address. And so we used email addresses when we had them to solicit these authors. So we invited over 100,000 invitations. We sent out over 100,000 invitations to different authors. That's a lot of invitations, a lot of authors. We don't know of those email addresses which ones were valid or which ones people might have left or changed jobs or graduated or whatever, right? We have no idea. So it wasn't too surprising to us that only a quarter actually opened the invitation that we sent them, but there's large attrition there from the number we sent invitations to the number that opened the survey. Of the people that opened the survey, 3,700 started the survey, and then we ended with about 2,700 that finished the survey, and that 2,742 completed the 2,742 completed the choice experiment. So that's the sample size that we wanted. And going from here to here doesn't it hurts a little bit, but 2,700 responses for a choice experiment is still quite large. So we're happy about that, even though of course there comes with all the caveats of there may be bias. But for a web solicited cold call email, this response rate isn't atypical. We're sort of okay. Okay, so and it's also sort of borne out by the types of respondent characteristics that we have in the survey. So we had a mix, but many more male than female. We had middle sort of age ranges. Many more biophysical than social sciences, but some that identified as interdisciplinary or other. Almost all of the respondents had doctoral degrees, though a handful of master's degrees as well. And most were at educational institutions, but also a mix that were affiliated with NGOs or government as well. And this, just a little bit of the other data that came out of the survey. This is a little bit of a one-off, but I put this in here from a conversation we had at dinner last night, that we also asked respondents about the places that they worked, so the field settings that they were most familiar with, and we asked them about different types of co-impacts. So this is a little bit of that directionality part that we can't pick up in the evidence map. Is it a positive relationship or is it a negative relationship between these different types of NCS measures and the co-impacts that we might see, right? So positive things would be things like job creation, improving land tenure security, improving material benefits, or somehow improving like cultural or spiritual benefits with the land. And negative things would be like displacement, right? Are you being moved off the land, increased marginalization in some sense, or trade-offs for food or trade-offs for like economic development, right? And so this is actually data that we're still sort of working on and developing too, but just to show that this is also the kind of stuff that we have in the survey. All right, so back to the choice experiment. So the core choice model results, I had mentioned that the choice experiment framing is a little different. So we actually have a paper under review right now that sort of just sets out the choice experiment framing as a way to elicit experts instead of getting individual willingness to pay. And our core choice experiment results are here. I think I'm not going to go into these in too depth, but I'm happy to talk about them if anyone would like to. This is maybe a little bit more discernible, but what these show is that our predictions do show differences across all the respondents for different types of restoration activities in these different settings. So you can see here, for example, that for relative income categories that almost across the board for all different restoration types, in low income settings, the respondents showed that almost all of the restoration activities were more preferred or more acceptable, right? High income settings somehow received less acceptability or less preference. But part of the interesting thing here, for me anyway, was that different restoration types were also really spatially different, right? So if we look at the restoration types, that sort of win, the ones that have the highest level of predictive power for someone making a choice, the ones with the highest preferences are different based on different regions as well. Okay, so it's not just, there isn't one sort of blockbuster action that everybody's predicting. It's nuanced and it varies across the different types of settings that we've set up. Yeah. Okay, so then we take these results and then we're going to do the spatial prediction exercise, put them back onto the landscape. Okay, methods. Okay, so just first quickly, from the core model results, we can see that there are different types of restoration activities that are most preferred in different areas, right? And so reforestation, there's a lot of reforestation action that's predicted. So these are broken down by sort of the areas in the different regions of the world, partly constrained by what is restorable for any of these given restoration types, right? But the spatial prediction exercise says that these different types of lands or different restoration activities would take up this much space in these different regions. And if we look across the different regions, then we do have a mix of those different restoration activities as well. And so this is our global prediction map with a couple of zoomed in features, also noting that these are our preliminary results. There are some things that we still want to do to make these more precise and better. And all to say as well that, it's not that we think that each of these pixels actually represents a place that should undertake that particular restoration action, but most of the prioritization maps that you see are based on what is the highest carbon value restoration activity, or for a given opportunity cost of implementation, what we put onto the landscape for restoration. And this, at least I think, presents a step forward in trying to integrate ideas of what is happening locally and how this integrates or interacts with local communities and local development options in a way that says, well, we know what parts of the landscape are restorable, but then what would be preferred based on those restoration action or based on those contextual conditions. Okay, and so with this, another question we asked ourselves is, does this really just reflect the restoration potential maps? And this is just a zoom in for Africa if you can see it. But if our restoration maps only had, for any given pixel, if there was only one restorable type of activity, then that would be the thing that you would choose. But there are lots of pixels where restoration could take multiple options. At least most of the pixels, there are at least two competing restoration options for all the pixels that we have in our data sets. And one of the things that we're updating with this, I think, is actually going to increase this having more than two or more viable options as well. But at least on our first run, still most of our pixels had at least two options that were viable. And so we're the expert informed prioritization here gives us a way of saying, well, which of these options should be chosen based on some sort of socially informed information that's not just like, well, choose the one that stores more carbon. Okay, and so in conclusion here, so we haven't didn't talk about it as much, but the methods here are useful for systematically evaluating expert preferences, which is how we often make a lot of these kinds of decisions anyway, but haven't been really systematically, we don't have systematic ways of developing expert preference decision-making processes. But we think these expert assessments are actually useful for a lot of policy decisions, and they're very commonly used. And this presents a new way of actually using choice experiments to do this kind of spatial prediction. We can't find any other, there are lots of choice experiments happening, but we can't find any that do spatial prediction in quite this way. So we think that's a contribution as well. And hopefully this kind of work does help inform some of those big issues that we talked about in the very beginning around, can natural climate solutions actually work? How do we meet conservation targets in equitable ways? And how do we choose areas to protect? And with that, I'll say thank you.